Algebra 1, 8-1, adding and subtracting polynomials. So we've got a monomial, and we've got a binomial, and a trinomial. So we're going to look at what each of these terms means. A monomial, here I'm just going to show you some examples. One is 5x, x times y cubed, and 10. These are all monomials. Notice there's nothing being added or subtracted from any of these. These are just one term each. Binomial, 2x squared plus 7, that's a binomial. 5y minus 2 is a binomial. AB minus AB squared, those are all binomials. Notice there are two terms in each of these. Trinomial, x cubed plus 10x plus 1, x minus 2y minus 8, 2a plus b squared minus c. These are all trinomials. Notice 1, 2, 3 terms, 1, 2, 3, 1, 2, 3. These two groups here are polynomials. It just means more than one monomial polynomials. You could have 4 terms, 8 terms, whatever. More than 1, 2 or more, gives me a polynomial. All right, now we're going to look at monomials for a little bit before we move on to polynomials. We're going to look at the degree of a monomial. Degree of monomial. The degree of a monomial is the sum of the exponents of all the variables. Sum of the exponents of all the variables. So we're going to do some examples here. So I'm going to have a monomial, and then we're going to show the degree of that monomial. So if I have a cubed times b squared, this is the monomial. My degree is 3 plus 2, which is 5. If I have x, y cubed, my degree is 3 plus 1, or 1 plus 3, 4. If I have j, k squared, h to the 4th, j is 1 plus 2 for k and 4 for h. 1 plus 2 is 3, plus 4 is 7. So hopefully that helps kind of figure out how to find the degree of the monomial. Now let's do the degree of the polynomial. Degree of a polynomial, similar to the monomial, but then you just have to decide which term or which monomial is the biggest, the greatest. So this is the degree of a polynomial is the greatest degree of any term in the polynomial. So when we're talking about any term, we're talking about individual monomial. So whichever one is the greatest, that's the one that is the degree of the polynomial. So let's do an example here. So we're going to have a few questions that we're going to ask for each of these. There's going to be 4 examples. And we have a few questions that we're going to ask for each one. Is this a polynomial? Is it a monomial, a binomial, or trinomial? And what is the degree? All right, so this first one is going to be 4y minus 5xz. Is this a polynomial? Yes, it's got these two terms here. So yes, it's a polynomial. And there are two terms, so it's a binomial. And the degree here, so now I need to find the degree. And so for this term, I've got y to the 1 power. So the degree of this one, of this term, is 1. Now the degree of this one is, I've got x raised to the power of 1 and z raised to the power of 1. So 1 plus 1 is 2. So this is the degree, 2. The greater term, the term with the greater degree, is the degree of the polynomial. All right, B. Negative 6.5. This is a monomial. As we looked up here at the beginning, 10 is a monomial. So negative 6.5 stands to reason would also be a monomial. And the degree for this one is 0 because it has no variables. The variables tell me what the degree is. And if I don't have any variables, then the degree is 0. All right, see? I've got 7 times a to the negative 3 power plus 9b. Now, I've got these two terms here. And we haven't discussed this, that's why we have these examples down here at the bottom. If this a, notice how is to the negative 3, that means that this is going to be 7 over a cubed plus 9b. This issue right here, so I had to put that, so it goes down there. This issue tells me this is not a monomial. So therefore, this whole deal is not a polynomial. And last one we're going to do here is 6x cubed plus 4x plus x plus 3. Now, before we can figure this one out, we need to combine these like terms. So we're going to look at this in just a minute. But this is 4x and this is x. I can't add these two to the x cubed, but I can add these two together. So I'm going to simplify this a little bit. 6x cubed plus 4x plus 1x is 5x plus 3. Now I'm going to decide which of these is the greatest degree. So here I've got x to the third, so that monomial there is the degree of 3. This one is 1, x to the 1 power, and 3, that one's 0. So the greatest degree here is 3. My degree is 3. Yes, this is a polynomial. I didn't write those down, but that's okay. This is a polynomial, to answer the questions. And it is 1, 2, 3, a trinomial. And the degree is 3. All right, let's keep moving on. Polynomials in standard form. Polynomials in standard form. Here's an example. 4x cubed minus 5x squared plus 2x plus 7. This number right here that's in front of this leading term here, this is called the leading coefficient. Now this polynomial here has a degree of, so this would be 0, this would be 1, this would be 2, this would be 3. So the degree for this guy is 3. The greatest degree of the monomials is this one, 3 degrees. So the standard form here, notice how it goes 3, 2, 1, 0. So for standard form, we list the terms from greatest degree to smallest degree. And there we have it. Now, let's do some examples here. So here's your example. Write in standard form and name the leading coefficient. Okay, so we're going to write in standard form. And name the leading coefficient. All right. So let's do one together, and then we'll have you do one on your own. This first one here, we got 3x squared plus 4x to the 5th power minus 7x. All right, so I'm looking at each of these, and this one monomial goes to the power, has a degree of 2. This one has a degree of 5, and this one has a degree of 1. So this guy needs to go to the right, and then it'll be this one and this one, greatest to smallest. So 4x to the 5th plus 3x squared minus 7x. And here is my leading coefficient. 4 is my leading coefficient. All right, now you try one. 5y minus 9 minus 2y to the 4th power minus 6y cubed. All right, write this in standard form, greatest to least degrees, and then name the leading coefficient. All right, go ahead and pause and go. All right, let's see how you did here. Okay, so this one is a degree of 1, this is a degree of 0, this is a degree of 4, and this is a degree of 3. All right, so this one's going to go first. Negative 2y to the 4th power. Notice this negative, or this minus, comes along with the term. Minus this next one, 6y cubed. These guys are done. And then plus 5y minus 9. So now I've got 4, 3, 1, 0. And here's my leading coefficient, negative 2. My degree is 4. My leading coefficient is negative 2. All right, there we go. It's good. Next, we are going to add polynomials. Here's the rule. Before we get started, let's do this. Let's get this rule out of the way. Rule. You may only add or subtract like terms, and then I'll define what like terms are in just a second. You may only add or subtract like terms. Here's what a like term is. Like terms are the same variable, so the term has the same variable or variables raised to the same power. Okay, so let's do an example here and see what we're talking about. So first we're going to say, okay, here's an example to kind of help see what some terms are. So I'm going to write a bunch of terms here. So I've got x, a, x squared, ab, y cubed, 5x squared, 2x, 7ab, and 25y cubed. 25y cubed. Okay. Now I'm going to try to find the like terms here. So I'm going to look at this x, and I'm going to look for any like terms. So I'm going to circle this x. Any like terms, the terms that are like this x. So I'm looking at this one here. This is x squared. I've got the same variable, but this is raised to the power of 1. This is raised to the power of 2. These are not like terms. So this doesn't have x, this doesn't have x, this doesn't have x. This has x squared again. I don't want that one. This one has x raised to the power of 1. X raised to the power of 1, x raised to the power of 1. These are like terms. I can add these together. 1x plus 2x is 3x. I can subtract them, whatever I want to do. There aren't any other like terms here for this x. Now I'm going to look at the x squared. I'm going to triangle the x squareds. There's x squared here. Here's another x squared. These are like terms. I don't see any other like terms. Now let's look at this a. Let's look at this a here. I don't see any other only a's. Notice how this one is ab. These are not like terms. This is a times b. So these are not like terms. A is all alone. There aren't any other like terms here to this a. AB, however, let's do an upside down triangle for AB. There is another term here that has AB in it, and they're both raised to the power of 1. There we go, upside down triangle. Now let's check this y to the y cubed. Here's another y cubed, and these, so this is 25y cubed, the same variable, raised to the same power. I'm going to box those in, and now these can be added or subtracted. Only like terms that have the same variables, raised to the same power, those can be added or subtracted from one another. All right, let's do an example that looks like an expression. So I've got 2x squared plus 5x minus 7 plus 3 minus 4x squared plus 6x. So I just need to add these together. Now, since this is plus here, I can just ignore these parentheses because I'm just adding them together. So I can ignore all the parentheses. So I'm going to rewrite this without the parentheses. 2x squared plus 5x minus 7 plus 3 minus 4x squared plus 6x. Okay, now there are several ways we can go about doing this. One is we can circle all of the x squareds, and we can make a triangle or a box or a rectangle around all of the x's, or we can just talk through it and look at each one. So it's up to you the way you want to do it. For this example, I'm going to use circles and squares and stuff so that you can see what we're doing. And in the future, we might not do it that way, but you can do it that way on your own if you want. So I've got x squared. I'm going to circle this. I'm going to look for terms that are like terms with this x squared, 2x squared. This is not x squared. This does not have x squared. Neither does this. This does have x squared in it, and there aren't any other variables. So negative 4x squared and 2x, these are like terms. 6x, not x squared. Okay. Now 5x. I don't see any other x's that aren't x squared, so there it is, 6x squared. Now, these guys here are like terms as well. Hey.
Hi, the menu.
Thanks.
In case any of the kids are wondering.
And then these two both have, these do not have a variable. Negative 7 and 3, these are like terms. So we can just combine those as we know we can do already. All right, so let's start combining stuff. Should we triangle these? Okay. Squared and squared, x squared and x squared. Positive 2, negative 4, that gives me negative 2x squared. All right, those are done. Now I have 5x and 6x, and they're both positive, so that's 11x. And then I've got negative 7, positive 3, negative 4. So this is my polynomial after I added those two together. Okay, now you try one. I've got 3y plus y cubed minus 5 plus 4y squared minus 4y plus 2y cubed plus 8. All right, add these two guys together and let's see how you do. Remember, you can only add or subtract like terms. Same variable raised to the same power. Okay, go. All right, let's see how you did. So you might have grouped your like terms with circles or squares or rectangles, whatever, triangles, however you want to do it. I'm going to show you another way here as well. So I'm going to look at the y cubes because that's the greatest degree. So I'm going to do those first. So I see I have a y cubed here and I have a y cubed here and I don't have any other y cubes. So 1y cubed plus 2y cubed, that gives me 3y cubes. 3y cubed. And now that I'm done with those, I'm going to cross them off. And now I'm going to look at the y squared. There aren't any y squared here. There is just this one y squared. So I'm going to say plus 4y squared. Now I didn't rewrite this whole thing because this is just plus right here. If this was minus, then I would definitely need to. So I'm just ignoring the parentheses because I'm adding. Now I've got y that's not squared or cubed and y to the first power, y to the first power. Positive 3y, negative 4y, negative 1y. Negative 5, positive 8, positive 3. There it is. Notice how I'm not changing the exponents at all when I add y cubed to 2y cubed. I'm not saying 3y to the 6th power, right? The powers stay the same. They don't change when I add and subtract. All right, we've got a little bit more to do, and then we'll be all done with 8. Is that what chapter we're on? 8-1. Just a little bit more. Let's go ahead and look at this. Got a couple, one more you try, and then 2 more examples. So 3 more examples total. 5x squared minus 3x plus 4 plus 6x minus 3x squared minus 3. So this is very similar to the last one. I want to just give you one more shot at it. Okay, go. All right, again, this is plus here, so I can just ignore the parentheses. If the parentheses are bothering me, I can just rewrite the whole thing. That's okay. 3x plus 4 plus 6x minus 3x squared minus 3, just so that I don't have the parentheses anymore. Now I'm going to find my greatest degree term here, and that's the squared and this squared. So I've got 5x squared. I don't see any other x squareds except for this one. So 5x squared minus 3x squared is 2x squared. So I'm going to cross those off. And then I have x, negative 3x, and positive 6x is going to get me positive 3x. I'm going to cross those off. And then 4 minus 3 is 1, plus 1. That should be my answer there. All right. 2 more examples, and they are going to be subtracting polynomials. So subtract polynomials. Here's my example. 3 minus 2x plus 2x squared minus 4x minus 5 plus 3x squared. Okay, so now I have a subtraction sign here. I've had addition signs here the whole time. Now I have subtraction. So I can't just ignore my parentheses. I need to distribute this negative in here, and then I can ignore my parentheses once I'm done with that. Dude, so much folding of paper. What is going on over there? 3 minus 2x plus 2x squared minus 4x plus 5, so I'm distributing this negative here, minus 3x squared. Okay, now I'm going to look at the find my like terms. Here's my squared, here's my x squared, positive 2, negative 3, so negative 1x squared. I'm going to cross those off. Negative 2x, negative 4x. I don't see any other, just x's. All right, so negative 4 and negative 2, that's negative 6x. And then 3, I'm going to cross those off so they're out of the way. 3 and 5 is 8. And so there's my answer for that one. Okay, one more. And this one is for you to do on your own. 7p plus 4p cubed minus 8 minus 3p squared plus 2 minus 9p. Okay, so you're going to do this one on your own. Make sure you distribute that negative in there before you ignore the parentheses or make them go away. And then subtract, add the like terms, combine like terms. Okay, pause and go. Okay, let's see how you did. Distribute, distribute, distribute. Rewrite this, 7p plus 4p cubed minus 8 minus 3p squared minus 2 plus 9p. So I've just switched the signs for everything in here because they're being multiplied by negative 1. Negative, negative, positive. Find my like terms. So here's a p cubed. Looks like that's the only p cubed that I have. So 4p cubed, that goes away. And now I'm going to look for p squared. Look, that's the only p squared I have. So minus 3p squared, that goes away. And now I've got a 7p and a 9p and don't see any other p's. So plus 16p, those go away. And then I've got negative 8 and negative 2, negative 10. And that is hopefully what you got for that U try. And that is the end of 8-1. And good luck on the homework.